In this video, we're going to take a look at a couple of different limit exercises dealing with the square root function. Here's a graph of the square root function. It looks something like a parabola that's been turned on a side that only has the top half, not the bottom half down here. So here's the first question. What's the limit as x approaches 0 of this square root function? So here's x equals 0, and you notice something kind of weird happens here. Is the left endpoint of a curve, it doesn't continue past 0 because you can't take the square root of a negative number. So we just need to think about what we would need to do here. Now, in some sense, it kind of looks like the limit would be 0 because the function does, in a sense, kind of tend towards 0. But then if you're paying close attention, you'll notice there's nothing going on over here on the left-hand side. So the question is does that matter? Should we ignore it? You know, what's the deal? What do we do here? Well, we really have to know the fine details as far as what a limit means. If you recall, a limit determines what value a function approaches, like square root of x, as x approaches c from both sides. And so the only way that a limit could exist, a two-sided limit, like a normal regular limit like this, is if the limit from the left-hand side matches the limit from the right-hand side. So first of all, they have to agree, or they have to exist from both sides independently, and then whatever they exist as, those numbers have to match each other. So that's very important. So if you were to take your hand and kind of cover up the left-hand side right here, it would be very clear from this side the limit would be 0, right? It's nose diving down to the origin. But if you covered up the right-hand side and you couldn't see what was going on over here, and you ask what's the limit as x approaches 0 from the left-hand side, the other one-sided limit, you would see there's nothing. There's no graph. There's nothing going to the origin. Now you might say, well, Devin, it is defined at the origin. Well, remember, we know that means nothing because limits don't care what happens at C. You know, we've seen plenty of examples that have had, examples like this, where you've got a hole in the graph and the point's defined somewhere else, but yet the limit still exists and is this, wherever the hole is, even though the value is defined somewhere else. We completely don't care that it's defined at 0 at the origin. That's irrelevant. So what does this mean? Well, this means that the two-sided limit, believe it or not, actually does not exist, right? This limit does not exist because there's not two one-sided limits from the left and from the right that agree with each other. Now, here's what we can say, though. Here's what we were intuitively thinking, but we just have to be careful how we say it. What does exist is just the one-sided limit. Now, if you put a little plus sign in the upper right-hand corner of whatever your constant is, then that indicates you're coming to that number from the right-hand side only. So the one-sided limit would exist and it would be 0, but the two-sided limit would not exist, again, because it's not defined to the left of 0.